Welcome to the catmanAP webinar, where we'll show you how the software Catman enables you to set up a measurement using strain gauges. In the next couple of minutes, we'll configure our amplifier according to the strain gauge parameters printed on each individual package to measure microstrain. Finally, we'll calculate the mechanical stress and display the results. Now, in our example, we have a strain gauge rosette with 3 individual quarter bridges. Each grid has a length of 3 millimeters and a resistance of 120 ohms. Our aim is to display the magnitude of the main stress and its position described by an angle. After the device scan, you can see the QuantumX system finds 16 channels and places them in your channel list. We name the first 3 channels and save some time by selecting all 3 channels at once using the auto naming function. Now we have to tell the amplifier what we've connected. We look for the appropriate strain gauge in the sensor database and assign the 120 ohm quarter bridge connected via 4-wire using a simple drag and drop. Immediately we see values in microstrain and know that we are done with the basic setup. Because our bending beam is now in an idle state, we'll run a 0 adjustment. To finalize the setup, we want to specify the strain gauge parameters according to its datasheet. Now to do that, we open the strain gauge configuration with a right mouse click. To define the strain gauge settings, we need the datasheet of the strain gauge to be used. Most important is the gauge factor. If we would like to compensate temperature effects on our measurement, we could choose between 2 methods. Both can be configured within this window. You can either use an additional strain gauge. This passive strain gauge sees no mechanical stress, just the thermal stress. Our Catman software will subtract that value to extract the mechanical stress. Alternatively, we could measure the temperature with an additional thermo channel and use the response polynomial from the strain gauge datasheet. But in our case, we do not expect big temperature changes during our measurement. Therefore, we'll refrain from using temperature compensation at all. That means we're ready to measure microstrain. Now we want to create math channels to calculate the mechanical stress in real time. We open the dialog to create computation channels from type strain gauge stress analysis. Defining a name for our computation channels will help us later on finding these channels much easier. We'll tell Catman which channels measure our 3 grids. Just drag and drop. And define what physical quantities we want to see. We'll choose the angle and principal nominal stress 1. Finally, we can configure the type of the rosette and the material of our bending beam. In our case, we have a 45/90 degree rosette and we use standard steel. Therefore, we can continue with the default settings. Please note that we got 2 new channels in the list. First, principal nominal stress and the angle. To prepare our panel for monitoring our measurement, we switch to the visualization page and drag-drop our calculated first nominal stress channel onto the empty panel. We choose real-time graph when Catman asks us how we want to display it. To add the angle to the graph, we should use a second layer. Now this can be set in the configuration dialog of the graph. To assign the angle to the second layer, just drag and drop it. Now we start the data acquisition and immediately we see our stress values from our bending beam, the magnitude and direction of the main nominal stress. For example, we can see that a simple bending only affects the magnitude and the direction of the torsion as well. With some mouse clicks, we're able to run a strain gauge rosette measurement within the so-called mechanical stress analysis. We simply set up our data acquisition system and defined our strain gauge parameters before we created virtual math channels to calculate our stress values. Now, we can take the results to our report. Well, thanks for your attention and have fun and much success working with catmanAP from HBM.